and he has been a collaborator of the group for some time, and in fact, he spent a sabbatical with us here, a full year. We've met very recently in Cancun for a workshop that was organized within the New Fanfico network together with the division of mathematical physics of the Mexican Physics Society. So that was really nice. It's a pleasure to see you here once again. So please, Darío, the floor is yours.
Thank you, Carlos. Hello, everyone. Yes, I'm very happy to be here at the celebration of the Strong Gravity Group in Aveiro. And I want to share with you some memories and some ideas. It will be, I hope, short, and then we can discuss later. So I start by mentioning that I think that we are already facing a big challenge because for nearly already 100 years, the interpretation of the data, the observational data using our known valid equations, we hope, are telling us that there are large amounts of unknown matter. And we know that there is already, unknown matter, but the question is, what is it? We have been already for more than almost 100 years trying to understand what is the nature, what is there, and that's what is the challenge. How can we actually determine what is, and it's already a long time. People are already saying, well, what's happening? And as a challenge, I think it presents a large risk, many large risks, and also an amazing opportunity. Perhaps the largest risk is that we can choose a subject of research in this area, which actually leads nowhere. And then the time was not that well spent. So I think the challenge is actually to pose a clear question. What do we want to solve? What do we want to get to? And of course, the gravitational group in Aveiro, which is celebrating, and that's what we are now celebrating, is standing up to that challenge. And for the last 15 years, and with the excellent leadership of Carlos and Eugene, they have produced a series of landmark works. I think that the most remarkable are the ones regarding hairy black holes and the development of rock stars as a feasible dark matter model. And then, well, of course, I want to congratulate all these results of the group that you have formed, Carlos and Eugene, and keep the good work. Regarding my interaction with the group, it was Juan Carlos de Gollado who for us discovered the Aveiro group, and actually he made the first contact with the Graph group with Carlos. And from October 23, I had the opportunity to have my sabbatical stay in Aveiro and interact with the group, mainly with Merced, with Carlos, with Hector, and with Miguel, together with my former postdoc, PhD student, and now postdoc and collaborator, Victor Jaramillo. I had the pleasure to work on many subjects like the Newtonian potential, shadows, Q in Q balls, electric and magnetic boson stars, and I really enjoyed that kind of subject. And also I had many enlightening and passionate discussions with Pedro, with Eugene, and of course with Carlos, and with many PhD students, mainly Etevaldo and Nuno, I remember very nicely. So my impression and my memories is that it is a very pleasant group to work with and to have the most interesting and passionate discussions with. So, of course, several of the collaborations go on up to date. And going back to the challenge, in my opinion, it is worth planning the aims of the research. Besides that you like the subject or you are just giving the next step, we have to carefully see what do we want to prove and then try to have some mainly observational consequences. As Carlos mentioned just now, we met in Playa del Carmen a couple of weeks ago. And yes, he there mentioned that there are no astrophysical, at that astrophysical scale, there are no observations that demand the presence of dark matter. So that is part of the challenge in at the cosmological and at halo scales. We do have the need to propose the presence, or we see that our equations tell us that we need the presence of large amounts of known matter in cosmological, at the cosmological stage. We can see that 95, 96% of the matter that should be, or has to be there according to our equations is unknown, and we have to understand that. At the halo scales, it is very clearly how the rotational profiles, curves differ if we do not take into account the presence of dark matter. However, at astrophysical scales, current observation seems to be consistent with the dynamics due to the observed matter, black holes included. So we need to think a little bit more what at astrophysical scale, what can we say or what can we do to actually determine the presence of the dark components. I think that the boson and the Broca stars and the hair have been already very well established and understood. So now the challenge is figuring out what are the actual observable consequences of these configurations. They are at astrophysical, and then try to make the model falsifiable. I think that, for instance, hairy black holes are very promising in the sense that we could understand certainly more details on the effects on the dynamics, on the shadows, and then try to see that there should be there, or if they are not, then what is happening? We have to look, I think, more carefully and in more detail these shadows. And I think that the strong group that is in Aveiro is able to face this challenge, and then using the abilities of all the participants, I hope that we very soon will determine or we learn more about the nature of dark matter. So long live the GRAB group at the University of Aveiro. Thank you very much.
Thank you very much, Darío, for the kind words. And also, I should say that there's a huge overlap of interests and scientific common goals with the Mexican community in terms of scalar field dark matter, for instance. And this has been really important, not only in the common projects that we have, but in every meeting that we are together, and we find that there is this potential of synergies. So it's great to see you. I mean, I missed our discussions. We had a little bit of that in Cancun, and I hope that we can continue them very soon. So
Sure.
Thank you, Darío.
Thank you.
Very good. So we should move